Good evening, guys. My name is Abraham Estrella. I'm from C209, Professor Diane's class, and my given topic to talk about in this video will be about photovoltaic systems. And to give a quick description of what these roofing systems are, is that they basically absorb solar radiation and convert it into electricity. So these are very like costly roofing systems to place on a given design. So they're even though they're very popular, um, they cost a lot, you know. So let's get into the video. Let's talk about their functions, like what are their use and stuff. Another name for photovoltaic roofing systems are solar shingles, and they're basically are solar panels designed to look like and function as conventional roofing materials, such as asphalt shingle or slate, while also producing electricity. Like I said, they look similar to asphalt or slate, but they also produce electricity. Solar shingles are a type of energy solution known as building integrating photovoltaics, BIPV. Basically, a source of solar energy where you obviously get energy from the solar radiation that you absorb. There are several varieties of solar shingles, including shingle-sized solid panels that take the place of a number of conventional shingles in a strip, semi-rigid designs containing several silicon solar cells that are sized more like conventional shingles and newer size and flexibility. These are also products using a more traditional number of silicon solar cells per panel, reaching as much as 100 watts DC rating per shingle. So the watt number for each of these shingles is about 100 watts. That basically means like the power that each of the shingles bring. Photovoltaic roofing um, materials are metal panels or shingles of asphalt slate, fiber cement, or metal laminated with thin film semiconductor materials and capable of converting solar radiation into electrical energy. Like I said, this process happens and it gets performed when each of the photovoltaic shingles absorb solar radiation. This is how it converts it to electrical energy. When they are installed as part of building integrated photovoltaic system, the electricity produced by these materials can be used to power a building's own equipment and systems, or where permitted by the public power utility, can be sold back to the utility to offset power consumption charges. Electrical power from BIPV systems is produced without pollution or the depletion of natural resources. So basically, you don't have to go out around and collecting what you call it, like natural resources and stuff, like to create to burn basically fossils and stuff. You don't have to pollute the air um in order for you to create this type of energy. All you need is solar radiation to convert it to electric energy. There's no need to introduce natural resources. There's no need for this. The essential components of a BIPV system are an array of PV modules, the PV roofing material, that's basically the photovoltaic materials that are needed, controller equipment to regulate the current generated by the models, and an inverter to convert the direct current output of the models to alternating current compatible with conventional building power. Standalone or off-grid BIPB systems, usually in the form of rechargeable batteries. So um, these type of systems, they kind of look like batteries because they need a recharge. So every like perfect way to let them recharge is during the day, because obviously that's where the most solar radiation comes. Um, estimating the potential power contribution of a BIPV system and evaluating its potential economic payback for a particular project require an analysis of the project's geographical location, solar exposure, projected power needs, utility costs, and additional factors. The average solar power roof shingle can easily last for 2 to 3 decades while delivering maximum energy output beyond its peak. It will still continue to produce energy, but has progressively reduced capacity. So, in the average lifespan of a photovoltaic roofing system is about like 2 to 3 decades, like 30 years. Yeah, so they last very long. So, um, these are very like useful when you want to absorb solar radiation to minimize the cost that you can waste. They help you reduce costs because you don't have to waste money on paying bills and stuff. That's an example. That's a good way to save up money. Also, they last long. Their longevity. Um, they could last 2 to 3 decades while delivering maximum energy output. So you don't gotta waste money to freaking like keep putting money inside. Not put money, but like recharging the batteries and stuff, like how you usually would do if you put a battery system to recharge your whole house. You don't need that. All you need is solar radiation. That's it. um they're good in size, like solar shrinkers. They're similar to traditional solar panels, but in terms of their size, they are smaller than most solar panels, which is good because you can place them in the right spots for the roofs. um the number of solar panel roof shingles it would take to power a home or a building would depend on the building size, and your average energy consumption. Basically meaning that the amount of photovoltaic shingles that you're gonna need are depending on the area that surrounds your home. That's how much, and also how much energy it's gonna take. Cause like if you have a big home, you're gonna need more photovoltaic shingles, and it's gonna consume more energy. You know what I mean? But even if you install just a few solar shingles, it will bring down your overall energy costs. Basically, saving you money, saving your pockets. um, for materials of photovoltaic shingles, um, many of today's solar shingles are composed of thin film solar cells made from copper, indium, gallium, selenide. That's what it's called. I don't know. This is what it's made out of. This semiconductor is known to have one of the highest energy conversion efficiency rates at about 12%. So this material is the best because it helps convert the solar radiation into electrical energy the best. Some of the photovoltaic shingles brands use monocrystalline silicon, which are usually costlier but have an average efficiency rate up to 20%. So basically, the more expensive the photovoltaic shingle, the more the better it will function. But even though like that to me, like that don't even matter because like just a few photovoltaic shingles would like power up your whole house. Like it does not matter. It don't matter. Um, some pros of photovoltaic shingles are that like if you're building a new home or like replacing your roof, solar power shingles could prove to be more cost effective because you will save and a tradition on the save on the traditional roofing material and labor. So it will cost you that whole process of labor of placing them on the roof and stuff. It's just gonna save a lot of time, to be honest. But yeah, that's all for this video. Thank you guys for watching. I really appreciate it. I hope that you guys learned something about photovoltaic on roofing, and see you in the next video.